Alright, so I'm gonna use Google's Code Lab because they are really good at explaining this topic. And for this one, the link is there, and I will add the link in the description for you to watch it or read it. We have this old shared preference which was used in the past, and Jetpack introduced DataStore, which aim to provide asynchronous API for storing data and reading from it. So they have made a comparison for each of these features, whether for shared preference that store, or a Proto that store. So I'm just gonna scale the screen up. That's a source if you want to copy it. And now let's get into the comparison. So for shared preference, it allow async API, and also it allow, and for preference data store, it's allow async, and prototype allow async as well. For the data store, they allow Flow and RX Java and Flowable. And for the shared preference, you will need to have a custom listener based on shared preference listener, and you will have custom implementation for that listener. And for synchronized API, it's allowed to be called on UI thread, but that's really not a good practice, because you don't want to have heavy loading on the UI thread. So as long as you keep your call on UI threads for that shared preference minimum, you will be fine. But if you want to do heavy loading, then you shouldn't make a call on the UI thread. And for the data store, this disallow the synchronized call on the UI thread. So this one is not allowed, whether it was for preference and the proto. And is it safe to call a UI thread? It's not safe, but the shared preference allow you to work on UI thread. Like, it will not show you any error, it will not show you anything, it will allow being used on the UI thread. And for the preference data store and proto data store, they disallow working on UI thread. You will not be able to work directly on the UI thread. So they move the work from the UI thread to the IO, which input output dispatcher, which is really good for working for doing heavy work, and it doesn't really, shared preference doesn't really signal an errors, not like data stores where they can show errors if you have like a problem with nullable objects or nullable values. You can have this kind of errors. And for this runtime error, unfortunately, shared preference doesn't really signal errors, so you can have some problem with exceptions. Preference data store, it tries to provide an error on compile time, so it can inform you need to fix an issue. So basically, it will help you from having those runtime exceptions. The same for each of those data store. And and to be honest, this transaction API strong consistency guarantee, I really don't buy this feature for one reason, because shared preference is kind of good and it was really being used a lot in the past. So I don't think that this is kind of true value here. So I will just ignore it. For data migration, you can have data migration from shared preference to data store, but you can't have data store to migrate to shared preference. And actually, you can have a migration from this preference data store to proto data store as well. And for type safety, shared preference doesn't allow type safety, and preference data store doesn't allow type safety. But proto data store provide data type safety with protocol buffers, which are just a neutral. Let me just show you. Neutral language provided by Google, like JSON and XML. They just work like this. They have different syntax than JSON as an XML, but that's a protocol buffer, and you can use it for handling for handling the type safety. So, and we will see how can we do that in the documentation later on. And for migrating, if you want, for example, to migrate to Proto DataStore from from preference DataStore, you can do it like this one has an error, and you can migrate just by returning this function, which is just like this. This function is just so easy. So the migration is easy for the DataStore, but it's hard for the shared preference. Alright, so that's it for our comparison between each of those feature and shared preference and DataStore, and we will talk more about room now. If we want to work with our room, it has like this one, but room is a complicated database because you will have queries, and if you want just simple storage in persistence disk, then you wouldn't really need to use a room database, because it's kind of not the goal of room database to be used for simple tasks. It's made for large and complex dataset where we have some kind of relationship between each table and each other. So that's kind of brief of how can of what each feature does, whether for shared preference, preference store, prototype, or each component, and the different trade between each of those components. We will see. We will start next by going in depth for our preference data store and the Proto data store as well. So see you next.